Right, let's make a start. Good afternoon, guys. It's Lee again. I have here the foundation tier paper, of the paper that I've went through earlier on. I've just finished recording the rest of the, or I should say the last part of the higher tier paper. If you're going to work along with this video, I suggest that you pause the video and find this paper in the description below. It's the AQA GCSE Maths foundation paper, foundation tier paper. It's paper 1, the non-calculator paper, and it's from November 2017. Have a go with the first 6 questions. They're the questions that I'm going to be focusing on in this video. I'm going to, just like I've done with the higher tier paper, with one video of that has already been released on YouTube. I'm splitting this up into bite-sized chunks. So have a go on your own of doing the first 6 questions, and then come back to this video. So let's make a start. Okay, first question. Circle the decimal which has the same value as 3/5. Okay, so there are a few things here that you may not have been shown in school. And the first of these is that you can use decimals and fractions. Now, you should never use a decimal in a fraction as a final answer, but it is fine with your workings. Okay, if it's something that helps you, then use it. So 3/5, well, that's quite close to 2.5 over 5, which is a half. Okay, but this here is bigger than 2.5 over 5, or bigger than a half. So we can use that information here to actually rule out these two answers straight away. They are both smaller than a half, so therefore they can't be solutions. Another thing here to note as well, that 3 divided by 5, well, that's going to be less than 1. So 3/5, I'll write it here. So 3/5 is, well, it's greater than a half, but it's less than 1. So that rules out that one, which gives us that as the answer, 0.6. Now, how else could you do that? Well, it's a good thing to know specific decimals and specific fractions, and one of the fractions that you should know is that a fifth is equal to 0.2. It's best to remember that because fifths come up all the time, and the opposite of that is true. If you ever see 0.2 as a decimal, then you can be certain that it's as a fraction, represented as a fraction. 0.2 is 1/5 or 1 over 5. So if 1/5 is 0.2, 3/5 would be 3 lots of 0.2, which is 0.6. Another way that you could do this is you could just use division. You could say that you could use short division. So we've got 3.00. So we have 3 divided by 5. Well, 5 doesn't go into 3. So we're going to have to say that's 0. Carry the 3 over. 5 goes into 36 times with no remainder. So that's it, we're finished, 0.6. So that's question 1. Question 2. How many millimeters are there in 7.5 centimeters? Circle your answer. Now, there is a easy way of doing this is to look at your ruler, I suppose. And I suppose a more rigorous approach is to remember that 1 centimeter is 10 millimeters. Or you may remember it as 1 millimeter is equal to 0.1 centimeters. So there are certain conversions that you should know. You should know that 1,000 millimeters is equal to 1 metre, and 100 centimetres equals 1 metre as well. So 1000 millimetres is also equal to 100 centimetres. So 7.5 centimetres. Okay, I'm just going to write this out again. 1 centimetre equals 10 millimetres. If we want 7.5 here, and we want to work out what that number is there in millimetres, to go from 1 to 7.5, we multiply by 7.5. So we have to do the same on this side. So 10 multiplied by 7.5 will give us this number here. And 7.5 multiplied by 10 is 75. In this case, millimetres. So there we go. Which of these shapes has 2 lines of symmetry? I'm just going to move the paper up a little bit. Which of these shapes has 2 lines of symmetry? Circle your answer. A semicircle, a rhombus, a trapezium, and an isosceles triangle. Well, before you can answer this question, you need to have an understanding of what these shapes are, what they look like, how are they defined. A semicircle will probably be something that most people watching this video will be very comfortable with. It's a circle that's been cut in half. So that's my very poor attempt at a semicircle. A rhombus is a very bizarre shape. I've always thought it's a bit strange. All 4 sides of the rhombus are the same in length, but they are angled with respect to one another. So it's as if you got a square, but you pushed the top across a little bit. So you know, all of these sides here would say have a length of 1, but this angle here would be the same as that one, and that angle there would be the same as that one. So it's a 4-sided shape with 4 lengths that are all the same, and the opposing angles are equal to each other. So that's a rhombus. A trapezium is another 4-sided shape. In this case, a trapezium is simply a shape that has 2 parallel lines that are connected. Now, these parallel lines, at one end, they can have a set of 90-degree corners, or sometimes they may not. These are both trapeziums. And finally, an isosceles triangle. But you should all know what a triangle is. It's of course a 3-sided shape. And an isosceles triangle is where 2 of the 3 lengths are identical to each other. So which of these shapes has 2 lines of symmetry? So, you know, what does that mean? Well, that means if you was to get one of these shapes as a piece of paper, you know, would you be able to fold it up in 2 different ways so that it was a mirror image of each other? So I'll demonstrate here with the isosceles triangle. If you were to fold that shape across that line there, that would be 1 line of symmetry. Now, still with the triangle, you know, could you fold that in a different way? Well, no. You know, you can't fold it horizontally because, you know, it won't line up neatly. The fact that this is an isosceles triangle means that you can't fold it any other way. So this isosceles triangle only has 1 line of symmetry. Okay, well, the trapezium, this is quite an interesting shape. Why is the trapezium interesting? Well, it's interesting because there are different variations of this shape. It can be like this with right angles on one end, or it can be like this where there are no right angles. So what that means is that this shape has no lines of symmetry. So that's that. Next we'll move on to the semicircle. So you might see where this is going. If you folded that shape in half, then, you know, this side of the semicircle would fold neatly onto this side. So that gives it 1 line of symmetry. Can you fold it any other way? Well, no, you can't. And it's very, very important to note here that when we're talking about lines of symmetry, it means that you can fold, say, this semicircle once in half, but then, so that counts as one line of symmetry. You then have to unfold it again before you try and work out another one. You can't fold this shape, so that, you know, you can't fold it along that line and be left with half a semicircle and then say, okay, well, we'll fold it along that line next and that makes two. You can't do that, okay? So, you know, that's wrong. So we're left with the rhombus. Now, the rhombus can be folded across that line there and this one here. So the rhombus has two lines of symmetry, which makes that the correct answer to that question. So that's the first 3 marks of that paper. It's always good to have a good start to a paper. You know, it builds quite a lot of confidence. But I'll put that underneath so that you can still see what paper we're working on, hopefully. Okay, question 4. Circle the number that is 7 less than minus 12. A lot of people struggle with negative numbers. When we first learn to count, we learn to count using the positive numbers, not the negatives. When we first learn to do basic arithmetic, we learn to add numbers, not subtract them. So adding positive numbers is something that comes very, very naturally to most people. But when you start subtracting numbers, when you start having negatives, that's when problems arise. One thing that I've always said to my students is never be ashamed to draw a number line. Never be ashamed to draw a number line. If it helps you get the answer, that's the important point. So always start your number line with 0 in the middle. And this here is saying circle the number that is 7 less than minus 12. So we have minus 12 there, and we're saying 7 less than that. So less than is another word for subtract or take away. When you take away numbers, you go towards the left on the number line, and we're going to go 7 in that direction. Okay, so we're subtracting 7 there. So minus 12 minus 7 will be minus 19. Now, if you can't see there, you know, why is that minus 12 minus 7? Why is it minus 19 over here? You know, why is it not minus 5? Okay, if you do 7 plus 12, you get 19. Minus 7 minus 12, you get minus 19. Okay, here if you're on minus 12, you go back 1 space, you'll be on minus 13, another space, minus 14. Do that 7 times, you get to minus 19. So there we go. So key point there, never be ashamed to draw the number line. Okay, the next question, x minus 3 equals 14. A lot of people doing the foundation paper struggle with algebra. It's nothing to be ashamed of. I think for the most part algebra is taught very weakly in schools. It's understood not very well by students, normally because they're not very comfortable with the foundations. So here, we want to work out what x is. And we know that if you take 3 away from whatever x is, if you take 3 away from it, the answer is 14. So we want to work out, well, you know, what happens if we don't take that 3 away? What will this number be then? So to do that, what we do is we add 3 to both sides of the equal sign, to both sides of the equation. Then on this left-hand side, we will have x minus 3 plus 3. Plus 3 minus 3, they cancel, and we're left with just x. Then on the right-hand side of the equation, we're left with 14 plus 3, which is 17. And that's our final answer. I may make a series of videos just looking at simple linear algebra like this. You know, I know that a lot of people, particular people, you know, that are struggling to get 3s and 4s, may really struggle with this kind of thing. So let me know in the comments if that's something that, you know, you'd find helpful, and I'll make another video about this in particular. And I suppose this links on nicely to these 2 questions as well. So the next one, solve 5y equals 45. Okay, so what does this mean? Well, 5y, that means 5 times y. 5 lots of y. Y is just a number, so 5 lots of some number gives you 45. So if you're quite good with your times tables, maybe you'll know that 5 lots of 9 gives you 45. So in this case, y is 9. If you're not so good with your times tables, that's okay. The way to do this is here we're timesing y by 5, so what we need to do is divide both sides by 5. So 5y divided by 5 will just be y, because if you have y and you times it by 5 then divide it by 5, that's just like timesing it by 1, or doing nothing to it at all. And then on the right hand side we have 45 divided by 5, and then if you don't know your times tables very well, just count up in 5s until you get to 45, and the answer will be 9. Move this up a bit. Final part of question 5. Solve 8 plus w equals 6. So here we're starting with the number 8. We are adding something onto it, and we are going down to 6. Okay, well, you know, how do we work this out? Well, if I rewrite this as w plus 8 equals 6, it's now very similar to this question here. It's now very similar to this question here. If the x here, we had x subtract 3. To get x on its own, we did the opposite of take away 3. We added 3 to both sides. So here, to get w on its own, we do the opposite of adding 8. We subtract 8 from both sides of the equal sign, from both sides of the equation. So w plus 8 minus 8 is just w. Then on the right hand side we have 6 subtract 8, which is negative 2. Again, if you're not very confident there with your negative numbers, remember, no shame in drawing a number line, always put 0 in the middle. We start off with 6, which is over here, and then we are subtracting, which means we go left 8 spaces. Okay, we are subtracting 8. So if we subtract 6 we get to 0, and then we need to subtract another 2, which will get us to minus 2. So w is minus 2. That's our final answer. Just a little bit of exam technique here. You don't have to, this here is the final answer. Just because they've left a little answer box here doesn't mean that you have to write that there. It is good practice too. It makes it easier for the examiner to recognise, you know, your answer straight away. All of this space here is given for your answer as well. Some people here will just have written down the answer, minus 2, and that's fine. But of course, if you need to have some workings, that's fine as well. Okay, so final question now, and this is quite a large question, 5 marks, it's in 2 parts. 6a is work out 9,174 divided by 11. Don't forget, it's a non-calculator paper. So how do we work that out? Well, we can work that out using short division. How many 11s go into 9? None. So 9 there will carry over to make 91. How many 11s go into 91? Okay, well, 8 11s are 88. So if we were to add another 11 there, we would be far larger than 91. We'd be 99. So the answer to that then is 8. So the difference between 88 and 91 is 3. Okay, 91 subtract 88 is 3. So that's our remainder, 3. So now we have 37. Well, how many 11s fit in 37? 11 times 3 is 33. So that there is 3 lots of it. 37 subtract 33 is 4. So we have 4 left over there, making 44. How many 11s go into 44? 4. We can no remainder. So the answer to this question, which was 9,174 divided by 11, the answer to that is 834. And finally, a fractions question. Lots of students hate fractions. You shouldn't let them, scare you too much. Fractions are easy. You just have to learn the rules and apply them in the same way with every question. When you want to add or take away a fraction, well, or I should say two fractions, the bottom number, the so-called denominator, needs to be the same number. So here you can see that this denominator is 6 and this one is 7. So this isn't a straightforward question. If this question was 5/6 plus 3/6, it's quite easy here. The bottom number will stay the same and we just add the top numbers, 8. And that would be the answer. Well, not quite, because this is asking for a mixed number, but that's how you would add those two fractions. So to add these fractions, what we need to do is when we want to add two fractions together that have different denominators, we need to do something called cross multiplication. And what that means is that we draw this funky shape, and if two numbers are joined together by a straight line, then we multiply those numbers together. So 5 times 7 is 35. The other top number will be 3 times 6, which is 18. The bottom number will be 6 times 7. 6 times 7 is 42. And then in this case here, the sign was plus, so we put the plus there. If that was a subtract, then it would be subtract. Okay, so in this example here we need to do 35 plus 18. So 35 plus the 10 is 45. You can break the 8 up into 5 plus 3. So 45, but if I say, you can break the 8 up and say that it's 5 plus 3. So then we need to add that onto that. So 45 plus 5 is 50, plus 3 is 53. And the reason why I've demonstrated that there is because this is a way that you can add numbers like this in your head instead of writing them down. Lots of people there would do something like this. They would say, okay, well, 8 plus 5 is 13, and then 3 plus 1 plus 1 is 5. Okay, well, when you start carrying things like this, it can be a little bit difficult to do that in your head. So learning to chunk numbers like this, this kind of approach can be quite helpful. Okay, now we've added these two fractions, but we haven't given our answer as a mixed number. To give your answer as a mixed number, you need to get it so that the top number isn't bigger than the bottom number. So we need to split this fraction up and say that it is 42 plus 11 over 42. So 42 plus 11 is still 53. The reason here why I've chosen 42 is because the bottom is 42. And then we can split this up into two fractions. 42 over 42 plus 11 over 42. Now, a number divided by itself is always 1. And then we add on to that 11 over 42. Now, we wouldn't leave the final answer as 1 plus 11 over 42. We would leave the final answer as 1, 11, 42. We wouldn't leave the plus symbol. And that's our answer. So hopefully you've found that a useful exercise. I'll go through the rest of the paper shortly. And I'll try and upload these as quickly as I can. In the meantime, if you'd like to see anything else, then please leave a comment down below, or get in touch with me on Reddit, or send me a message on YouTube. Anything at all that I can help you with, just let me know. And yeah, thank you for watching. I'll see you next time.